Welcome to Finding Volume of Solid Figures. We're going to review the volume formulas that we went over yesterday and then move into density. So hold on to your hats, as they say. First, we're talking about when we talk about volume of solid figures, what are we talking about? Is it A, the sound that comes from your TV or iPad? Is it B, the concept of having full bouncy hair? Is it a collection of written documents, i.e. newsletters or encyclopedias? Or D, the amount of space inside a solid figure? Please choose the right answer. That is right. Give yourself a pat on the back. Volume of a solid figure refers to the amount of space inside a solid figure. What are some examples? Water needed to fill a pool. The amount of jelly inside a jar. The amount of space inside a car's trunk. Air inside a mask, like for an astronaut. Clothes inside a suitcase. And ice cream inside of a cone. You come up with a few examples as well. Please place them in the chat. All right, so we're going to take a look at these solids. So we have prisms, we have cones, we have cylinders, and circles, as well as pyramids. What is volume? As you have just selected, the volume of a solid is the amount of space inside that solid. Consider the cylinder below. If we were to fill the cylinder with water, the volume would be the amount of water the cylinder could hold. Okay, all of it. Measuring volume. Volume is measured in cubic units. Here is a cubic centimeter. It is a cube which measures 1 centimeter in all directions. Notice how we have length, width, and height. So these are the 3 dimensions that we use. Okay, so we'll now see how to calculate the volume of various shapes. Volume of prisms. Look at the rectangular prism below. We must first calculate the area of the base of the rectangular prism. The base of the rectangle is measuring 10 centimeters by 3 centimeters. What is the base? That's right. The base is 10 by 3, which means how many blocks do we have if they're 1 centimeter apiece as well? So area of a rectangle is base times height, or I would think of it maybe as length times width. So the area is 10 by 3. As you guessed earlier, it's going to be 30 centimeters squared. We now know that we can place 30 centimeter squares on the base of the rectangular prism, but we can also place 30 cubic centimeters on the base to fill the prism. So notice how we fill the prism. So it's 10 by 3 or 30 cubic squares. All right, let's take a look at, now we have to find how many layers of 1 centimeter cubes we can place in the rectangular prism. Okay, we can fit in 4 layers. So how many cubes, how many 1 centimeter cubes are we going to have, or how much volume can this rectangular prism hold? That's right, it can hold 120 cubic centimeters. It means we can place 120 of our cubes measuring a centimeter in all directions inside our rectangular prism. So we have found that the volume of a rectangular prism is given by 10 times 3 times 4, the length times the width times the height, for 120 centimeters cubed. So this gives us the formula for a volume of a cuboid. Area of the base times height. You need to remember that the area of the base is going to be the length times the width. Okay? BH for short, but again, the B means the length times the width. Let's look at the volume of a triangular prism. The same principles apply to the triangular prism. To find the volume of the triangular prism, we must first find the area of the triangle base. It is shaded in yellow. Okay? Once we find the base, then we multiply the area of the base by B, by the height of the prism. So remember, this will give us the volume of the prism. So we are going to solve for the triangle here, or solve for the triangular rectangle. You need to remember that the base is actually going to be equal to the triangle side, which is 1/2 b base times height of the triangle. So remember, the little b is going to be equal to 7, and your height in this case is going to be equal to 3. Remember, that is a perpendicular line. So when we plug this in, we're going to get 1/2 is equal to 7 times 3 times just the 3, okay, which is going to be equal to 21 over 3, which will give us a base of how much? That's right, it will give us a base of 10.5. Then to find the volume of this figure, remember it's going to be base times height. Okay, so that means we're going to have the 10.5 times the 10. So that means that we're going to have a volume of, that's right, it's going to be 105 meters cubed. Okay. All right, pyramids are named by the shape of their base. In this case, we have a square pyramid because the length of side is 4 for each side. So each side is 4. Okay. The volume of a pyramid is 1/3 the volume of a prism with the same base area and height. So remember, B is going to be equal to that length times width, which means it's going to be 4 times 4. So if somebody can tell me, what does our formula look like when we start plugging in our values? Okay, so the volume is going to be, and go ahead and tell me what it looks like. That's right, it's going to be 1/3, and the base is 4 times 4, and then we times that by the height of 5. Okay, so that means that this is going to be 1/3 times 16 times 5, which means that this is going to be 1/3 times what? So that means that we have 1/3 times 80. We are going to divide that by 3, right? So we wind up with 26.7. These were meters cubed, so don't forget your units, okay? And that is our review of a pyramid. All right, let's look at the volume of a cylinder. Consider the cylinder below. It's 4 centimeters by 6 centimeters. It has a height of 6 centimeters. What is the size of the radius? Yes, the radius is 2 centimeters. So volume is equal to area of the base times the height. What is the shape of the base? That's right, the shape of a base is a circle. What is the area of a circle? Okay, so that means the area of the circle is going to be pi r squared. Okay, so we have 3.14 times 2 times 2, which gives us a value of 12.56. So then we're going to calculate the volume of the cylinder And that means that we have at 12.56 going 6 centimeters. So we're just going to multiply the 12.56 by 6 for an answer of, that's right, 75.36. Okay, so the formula for the volume of a cylinder is V equals B. Now notice that they use these B's, and you have to remember what the area of the base is, and in this case it's a circle. Okay, so that's the trick to these, and when they are testing you is they're just going to give you the B. That's really not the formula. The formula that you need to know is that it is the area of a circle for that base. All right, let's take a look at the volume of a cone. Consider the cylinder and cone shown below. Okay. The diameter d of the top of the cone and the cylinder are the same. The height of the cone and the cylinder are equal. Okay. If you fill the cone with water and empty it into the cylinder, how many times would you have to fill the cone to completely fill the cylinder to the top? Let's take a look at that. That's right, we filled the cone up once and we've dumped it in. How many times do you think you'll have to do that to fill the cylinder? That's right, 3 times. So it takes 3 times. This shows that the cylinder has 3 times the volume of a cone with the same height and radius. The experiment on the previous slide allows us to work out the formula for the volume of a cone. The formula of the volume of a cylinder is V equals BH, which really stands for V equals pi r squared times the height. We have seen that the volume of a cylinder is 3 times more than that of a cone with the same diameter and height. So the formula for the volume of a cone is 1/3 the base times the height. Remember that the area of the base you're looking for is going to be the area of the circle, which remember is pi r squared. All right, calculate the volume for the cone below. Notice, again, that our formula is 1/3 pi r squared times the height. What is the radius? That's right, the radius is 6 and the height is 9. So we plug this into our formula and we get that the volume is 339.12. Remember that we had to divide the 1/3, we had to divide our volume by 1/3 or by 3. All right, let's take a look at this next one. Now they give us the diameter and the height. The diameter is 18 meters. How much is going to be our radius? That's right. Our radius is going to be 9. So we get 1/3 times pi times 9 times 9 times 13. And now we get 1,102.14 meters cubed. Spheres. The definition of a sphere in space, the set of all points that are that are a given distance from a given point, is called the center. A sphere is formed by revolving a circle about its diameter. So here we have, what is the volume of a sphere? It's 4/3 pi r cubed. We are not going to find the surface area, we're just going to find the volume of the sphere. The radius is 12 centimeters. So notice that we're going to say volume is equal to 4/3 pi 12 cubed. So don't forget, you must cube your radius. So if you'll please enter that in, what is going to be our value? That's right, we're going to have a value of 7,238.23 centimeters cubed. All right, so that ends our volumes, and now we're going to take a look at density. Density equals the amount of matter per unit volume. So D is equal to mv, mass is usually expressed in grams, and volume is usually expressed in centimeters cubed or milliliters. Please remember that centimeters cubed is also equal to a milliliter. And so these may be used back and forth. So M stands for mass and V for volume, which is pretty nice. Sometimes instead of having a D for density, you will have the Greek sign of rho. So the D and V triangle for volume, mass, and density is as follows. Okay, so if you're looking for mass over volume, volume should be here. Density should be there. Notice how you have mass over volume, or if you just draw a heart and cut it in half, you have mass over volume. Volume is equal to M divided by the D. Okay, so both of these here are your divisions. Okay, and last, to find the mass, you just multiply the density and the volume together because they are next to each other. So that's D times V. What would take up more space, a kilogram of feathers or a kilogram of steel? That's right, the kilogram of feathers will be much larger than the kilogram of steel. Density is a measure of compactness of a material, how close the atoms or molecules are to each other. So the feathers, they're very light. So to get a kilogram of them, you have to have a lot of feathers. But steel, on the other hand, is very condensed, very close together. So steel is, you don't need so much steel to get a kilogram of it. More than heaviness, density shows how much space an object takes up. All substances have density, including liquids, solids, and gases. We're going to go through some examples. A small block of wood has a volume of 25 cubic centimeters and a mass of 20 grams. What is the density of the wood, and will it float in water? So you need to know that 1 gram per centimeters cubed is the density of water. So that is the density of water. This is a constant in nature. How to solve? Remember that density is equal to mass divided by the volume. The mass is 20 grams. The volume is 25 cubic centimeters. So all we do is have to divide these. Give me what the answer is. That's right, the answer is 0.8 grams per centimeters cubed for the density of your wood. Will it float in water? Yes, it will, because the density is less than 1 gram per centimeter cubed, which is the density of water. Solve the following problem. A rectangular block of copper metal weighs 1.896 kilograms. The dimension of the block is 8.4 centimeters by 5.5 centimeters and 4.6 centimeters. From this data, what is the density of copper? So notice how you're going to have to figure out what your volume is. They told you it was a rectangular block. And you're also going to have to transform your mass, because remember, mass needs to be in kilograms and grams, and in this case it's in kilograms. So how many kilograms, or I should say how many grams equal a kilogram? Okay, do you know that? So in order for you to have 1 kilogram of material, you will have 1,000 grams. Okay, so again, density is equal to mass divided by volume. In this case, the mass is 1.896 kilograms. Remember, though, that it's 1,000 grams per kilogram, so we get to move this over 3 spaces to the right. We're going to make it larger. Or you can think about it as multiplying it by the 1,000. Then the volume, we're going to have to take the length, the width, the height, the 8.4 times 5.5 times 4.6, and that's going to give us 212.52 centimeters cubed. Okay, we're going to put these together. We're going to divide the mass by the volume, and what is going to be our value? That's right. We're going to have a density of 8.92 grams per centimeters cubed.